Hello and welcome to Algebra 1, Chapter 8.5, and today we're discussing factoring differences of squares. And so this is a specific pattern that people saw when they were factoring. So before we get started on differences of squares, just want to review a few things, some things to ponder. So what does it mean to factor? Well, hopefully we are kind of on a common agreement. It means to write as multiplication. And that is what we've been doing whenever we factor, is that we are writing it as multiplication. So maybe if you start out with a trinomial, something in this form, that we've been factoring it into two binomials, but right there is our multiplication. And how have we been solving quadratics? And remember, quadratic is something with an x squared in it. How have we been solving these? We've been using the zero product property, which means that we set it equal to 0, so we get a times b equal to 0, and then we set both of our factors equal to 0. All right. And so what ways have we looked at factoring so far? Well, we've definitely done greatest common factor. We have factored by grouping. And then I would say we have factored into two binomials, and for that we've done two methods. We did trial and error, and we did what we called the AC method. Okay, so just as a recap, because you need to make sure that you've gotten all of these as we've gone along. So today we're going to look at factoring something in this form, and so how would you address that? Well, there's definitely no greatest common factor. Definitely can't do grouping because you have to have 4 terms. And when I say into two binomials, those were trinomials into two binomials. So where does this fit in? Well, nothing that we've done so far. Okay, so let me ask you this last question. When have we FOILed and lost the middle term? So can you remember back to when we were just FOILing and we lost the middle term? Well, that was when we had the product of a sum and a difference. So maybe something like this. And we said, okay, there's first, there's outside, there's inside, there's last, and those middle terms canceled. Hey, look and see what we got. So when we factor something like this, it's going to actually factor into two binomials. This is one of the few times you get a binomial to factor into two binomials, but it needs to be such that those middle terms cancel, because notice there is no x term. So that is what we call a difference of squares. And so here's our symbol. So it does have to be a difference. And the first thing has to be something squared, and the last thing has to be something squared. And it factors into the same thing, except one is a plus and one's a minus. And that's how we get that middle term to cancel. So you do always want to make sure that they are always differences of squares. So looking at this first one, this is m that's being squared. And this is 8 that's being squared, and it's a difference. So it's a difference of two things that are squared. This is your a, this is your b. You just wrote down that a squared minus b squared equals a plus b times a minus b. By the way, it doesn't matter which one's the plus or which one's the minus. So this is m plus 8 times m minus 8. And FOIL that real quick and make sure you get back to m squared minus 64. So this next one, so the question, to find your a and to find your b is, what are these terms squared? Well, this is going to be 4y. Make sure you're using really your exponent rules here to check that. And this is going to be 9z. It is a difference, and they are both two things that are squared. So we get 4y plus 9z times 4y minus 9z. Okay, well, this last one is not a difference of squares how it's written. And I can tell that in a few ways. 3 is not something squared. B cubed is not something squared. But if we keep in mind that we should always, always, always look for a greatest common factor first, what is it that these share? They share a 3b, and if we take that out, we end up with b squared minus 9. That is a difference of squares. Now the 3b has to stay in front, but then what we get is b plus 3, b minus 3. That whole thing there is your answer. So sometimes it requires you to factor more than once. Okay, so just see if we can go right into these. That's a 9, that's a t, they're both something squared. 9 plus t times 9 minus t. By the way, don't switch those because otherwise your minus sign will be in the wrong place. That's an 8g and an h. Okay, so 8g plus h, 8g minus h. Now, okay, I don't have something squared, so let's see if I have a greatest common factor. I think I have a greatest common factor of x, so let's pull out an x. 9x squared minus 4, so is that a difference of squares? Okay, the x has to stay out front. This is a 3x and a 2. 3x plus 2, 3x minus 2. Okay, make sure that whole thing is your answer. And this last one, we might try a few things. Let's take out a negative y. And the reason I want to take out a negative is because I want that minus sign in the middle. So negative y times 2y plus 3 times 2y minus 3. And again, that whole thing, there's your answer. Alright, so what happens when we have 4 terms? So remember when we went over this at the beginning of this video, how do you factor 4 terms? Factor by grouping. Okay, so let's look here. What do we got in common? 6x squared. So if we take out a 6x squared, that leaves us with x plus 5. Alright, and out of the next 2, well, 24 actually. So let's take out a negative 24. That leaves us then with x plus 5. And so this is going to be x plus 5 times 6x squared minus 24. And I probably did a bad thing here to begin with, is that if I look here, I still have a greatest common factor. And that greatest common factor is 6, and I probably could have taken that 6 out to begin with. I could have taken it out from the whole thing to begin with, and because I didn't, I'm going to have to take it out now. So let's bump that 6 out to the front. We're going to keep our x plus 5. If I take a 6 out of this one, you get x squared minus 4. And then we need to realize that x squared minus 4 is a difference of squares. And so this is what I was saying, that sometimes you might have to factor multiple times. So x minus 4 becomes x plus 2, x minus 2. And that entire thing there then is your answer. Alright, so let's check for greatest common factor to begin with. There's not one, specifically because x squared doesn't have a coefficient with it. So let's start with our grouping, taking an x squared out of the first two. So that would be 2x plus 1. Always put that 1 if you take out a whole term. Let's take out a negative 25. So that's going to leave a positive 2x plus 1. And that's going to result in 2x plus 1 times x squared minus 25. That x squared minus 25 is a difference of squares. They pop up all the time. Alright, so that results in x plus 5 times x minus 5, and that is our answer there. So we can try to use what we just learned to help us solve, still using zero product property. We haven't learned any other ways yet. So this is not a difference of squares, but so we're going to look for greatest common factor, and I'm thinking 3. Let's try 3. If we pull out a 3, we're left with 4 minus 9n squared. Does that work? Okay, that is a difference of squares then. So that's 2 plus 3n and 2 minus 3n. And really you should set all three of these equal to 0 because 3 is a factor. Alright, even though you're going to cross that one out, subtract 2, 3n equals negative 2. We get n equals negative 2/3. Negative 3n equals negative 2. N is going to equal a positive 2/3 because you're dividing by a negative. I'm going to skip the checks at the moment just because I know you know how to check. So you might check just to make sure. Alright, and we have one more here. Don't let the 1/4 scare you because that actually is 1/2 squared. And that's 5 squared. This is a difference of squares. We're going to get 1/2 x plus 5 equals 0. Alright, so actually let me finish factoring this here. 1/2 x plus 5 times 1/2 x minus 5. Okay, and you can FOIL that out to make sure, but that's going to give you a 1/4 and it's going to give you your negative 25. So set both factors equal to 0. So I already set the plus, so let's set the minus. And then solve both of these. So minus 5, 1/2 x equals negative 5. Go ahead, multiply by the reciprocal. Do not divide by a half. Remember, you can't divide by fractions. You need to multiply by the reciprocal. And our other one is 1/2 x equals 5 times 2 times 2. X equals 10. And again, you should check it, especially if your directions tell you to check it. But I will leave you with that at the moment. So let me know if you have any questions. We can get those addressed. If not, I will see you in class next time. Have a great day.